All right, so our next section in probability is compound probability, and more specifically, multiplication within the compound probability, because there's multiplication, compound probability, and then there's also compound probability that uses an addition rule, which is the next lesson. These are all just a refresher of definitions from the last set of notes. So outcome is the possible results. Event is a single or group of outcomes. Sample space is a set of all possible outcomes. Then probability is a numerical value from 0 to 1 that measures the likelihood of an event. Remember, it's the number of favorable outcomes over the number of possible outcomes. So a compound event is an event that is made up of two or more events. So like rolling a dice and spinning a spinner. Okay. Independent events are where the occurrence of the first event does not affect how the other event occurs, or how the effects of whatever happens in the first and second events do not affect the third event. Okay. So they do not affect each other. Dependent events is where the occurrence of an event does affect how the other event occurs. So if you are drawing cards from a deck and you do not put the card back, then that affects the probability of the next card that you draw. So in these two situations, if we have A and B are independent events, then the probability of A and B happening is the probability of A times the probability of B. So you just multiply the two probabilities together. If A and B are dependent events, then the probability of A and B happening is the probability of A times the probability of B after A occurs. And if it's a theoretical situation, you always assume that A happened. So if you're drawing a card and you don't actually draw a card, you assume that what you want the first thing to be happened, and then change according to that. Right. So for our first ones, we're just finding possible probabilities of A and B if we're given their final probability. So if we know that the probability of A and B equals 0.24, and we're going to assume that they are independent events, and it really doesn't matter in this situation, we need to find two possible probabilities that we can multiply together to get 0.24. So two things that when you multiply them together to get 24. So essentially, we're looking at the factors of 24. So 1 and 24, 2 and 12, 4 and 6, and 3 and 8. Okay. So we can say that A has a probability of 1.2, and B has a probability of 0.2. Because remember, it has to have the same decimal point. So if we're multiplying, it needs to have two decimal points. Or we can do 0.4 and 0.6, 0.3, 0.8, 0.24, and 1. Okay, any combination of those where you're gonna, when you multiply them, you'll have two decimal places. Actually, we're gonna change this one. We'll make it 0.12 and 2. And for some reason, it changed my pen. All right. So we have some more. So you have the probability of A and B equals 0.96. So we need the probability or the factors of 96 that are going to get us, when we multiply them, equal 96. I'm just going to cheat and use a calculator to get the factors of 96. Save some time here. All right, so 16 and 6, so we could do 0.16 and 0.6. Let's see. Do 0.12 and 8. Need the decimal for that one. Okay. So 96 has lots of options. If you don't know the factors of 96, there are a lot. So we have, for the next one, we have the probability of A and B is 0.56. So two numbers that multiply together to get 56 are 8 and 7. We'll just start there. So 0.8 and 0.7. Those ones are easy right off the bat. Boom. All right, so then our last one, we have the probability of A equals and the probability of B. And together is 0.144. 12 and 12 are possible choices, so we could make it 0.12 and 1.2 so that we get 3 decimal places. Okay. As long as your multiplication combo is 0.144. Okay. So moving on. A desk drawer contains 5 red pens, 6 blue pens, 3 black pens, 24 silver paper clips, and 16 white paper clips. If you select a pen and a paper clip from the drawer without looking, what is the probability that you select a blue pen and a white paper clip? So we're finding the probability of blue pen and white paperclip. I'm just going to abbreviate paperclip PC. So we have to figure out how many total pens we have. So we have 11, 14. So we have 14 pens. And then how many of them are blue? So 6 of them are blue. And because in this situation, I'm assuming that the pens and the paper clips are in different containers, the color of pen you pick does not affect the color of paper clip, so we don't have to do anything. We just need to write the ratio of white paper clips. So we have 24 silver and 16 white, so that's 40 total paper clips. And 16 of them are white. So we're going to just multiply those two together. I'm actually going to simplify these fractions first just because it's going to be easier to multiply. So this is 3/7 times 2/5. And now multiplying, you multiply the denominator. So 3 times 2 is 6. 7 times 5 is 35. And then that doesn't simplify. So the probability of picking a blue pen and then a silver paper clip is 6 over 35. Moving on. So there are 12 girls and 14 boys in math class. The teacher puts the names of the students in a hat and randomly picks one name. The student then picks another name without replacing the first. So what is the probability that both students picked are boys? Okay, so we're going to talk about this fact that she's not putting the first name back. So that's going to change what happens to the second name. So the probability of picking a boy the first time. So if we have 12 girls and 14 boys, we have 26 kids. And there are 14 boys the first time. So it's 14 out of 26. But then the second time, we have removed a name. So there are 25 total names. And because we're picking both boys, we're going to assume that she picked a boy the first time. So there's one less boy. So it's 13 instead of 14 now. We're also going to simplify this 14 over 26 before we multiply, just to make it easier. So 14 over 26 is 7 over 13 times 13 over 25. But we can also kind of simplify this 13 over 13 because there's a 13 in the numerator and a 13 in the denominator. So those are both going to become ones. So it's going to save us some time. So we have 7 times 1, which is 7, and 1 times 25, which is 25. So the probability of picking both boys is 7 out of 25. And then our next example. So Lita has a coin with heads on one side and tails on the other, and she's going to flip it in the air 3 times. What is the probability of the coin landing on tails up on the first flip and heads up twice on the last 2 flips? So we're trying to find the probability of tails, then heads again. The probability of the first and the second events do not affect any of the others because you're flipping the same coin over and over again. So the probability of flipping a tails is 1/2. Probability of flipping a head, theoretically, yes, I know that there's weight involved in this and that in actuality it's not 1/2, but theoretically it is 1/2. Probability of landing on heads is also 1/2. So we have 2 1/2s, and then we're just going to multiply all these together. So 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 again is 8. So the probability of getting a tail, heads, and then another heads is 1/8. So that is the probability that she's going to flip the coin in that combination. All right, and then we have 2 more examples. So Bill's golf bag contains 9 white golf balls, 6 yellow golf balls, 1 orange golf ball, and 1 pink golf ball. Without looking, Tim is going to take 1 golf ball out of his bag to tee off with, and then a different golf ball to putt with. What is the probability of Tim teeing off with a white ball and putting with an orange ball? I'm assuming this is not actually legal in golf. I don't think you can change the balls after you've hit the first one, but it's just a problem. We're going to go with it. So we need the total number of golf balls in his bag. So we have 9 plus 6 is 15, plus 1 is 16, plus another is 17. Ow, so the first one, sorry, Noelle just bit me. So the first is the probability that it's white. So there are 9 white out of the 17 total. And I'm just going to assume that in this situation that he's not putting the first ball that he hit back in the bag. So we're going to take 1 away because now there are 16 balls in his golf ball bag. Okay. And then the 9 is not going to change anything because it's white and then orange. So there's only 1 orange golf ball. Right? And now we're just going to multiply these together. So 9 times 1 is 9. 17 times 16 is, give me just a second here, 17 times 16 is 272. And I don't know if that simplifies. It does not. So the probability of a white and then an orange golf ball is 9 out of 272. All right, we'll have one more example. So a drawer contains 10 blue pens and 10 red pens. Without looking, Mrs. Stanton is going to take 1 pen from a drawer, use it, and then put it back in the drawer. Then she is going to take another pen from the drawer to use. What is the probability of Mrs. Stanton taking a red pen first and then a blue pen? So the key to this problem is this phrase right here, because she put it back in the drawer. Okay. So we have 10 of each, so we have 20 total pens. So the probability of picking a red pen first is 10 out of 20. And then we put that pen back, so it doesn't change the 20. So the probability of picking a blue pen is also 10 out of 20, which you can simplify both of them to 1/2. So 1/2 times 1/2 is 1/4. So her probability of picking a red pen and then a blue pen is 1/4. And that is the final answer, and that is the last example.